Before starting the session, I would like to introduce our first speaker, Professor Rakesh Sharda, sir. Dr. Rakesh Sharda is Principal Scientist in College of Agriculture Engineering and Technology, Punjab Agriculture University, Ludhiana. Sir has completed his BTech in Agriculture Engineering in 1992, MTech in 1996, and PhD. Specialization is micro irrigation protected cultivation and use of non-conventional energy resources in irrigation. Sir has research interest which includes precision farming and AI applications in the field of irrigation. Dr. Sharda has published more than 100 research papers and extension articles, books, chapters in national and international journal of repute. Sir has guided 5 postgraduate students and has delivered more than 500 invited lectures in micro irrigation and protected cultivation. From 2010 to July 2021, Dr. Sharda was principal investigator of Precision Farming Development Center, which is a project sponsored by Ministry of Agriculture, Government of India. And currently, Sir is chief scientist of All India Coordinated Research Project on Plasticulture applications in agriculture. Sir is also a member of Bureau of Indian Standards sectional committees on the Farm and Agricultural Division, solar pumps, and agro-textiles. Dr. Sharda is also a co-principal investigator in Center of Excellence to use brackish water to cultivate fruits and vegetables. Sir has contribution in micro irrigation and protected cultivation, which is very well recognized, and he has got funding for his projects from the agencies such as UGC, Department of Science and Technology, and International Rice Research Institute, Manila, Philippines. Sir has also been awarded by many appreciation certificates and awards such as Competitive Research Project under Indo-Egypt Call by DST. He is instrumental in executing various horticulture and soil and water conservation projects. Sir has also designed and recommended modified polynet house that the Farmers Commission has adopted, Punjab, to provide subsidies to the farmers. And Sir has also involved in research and teaching activities and provides training support to Punjab farmers and state government officials in micro irrigation and protected cultivations. So Sir has so many feathers in his cap, but with this, I will just like to summarize that with his practical experience and exposure in the area of this precision farming and AI application, I welcome Sir and I request to please give your address.
Well, my today's topic is science and technology for sustainable agriculture. You know what is the current problem the farmers are facing in Punjab or in this northern part? Can anyone tell what problem farmers are facing nowadays? It's lesser yields because of irregular or higher temperatures that they have experienced in the month of February. Mid of February to mid of March, it was very high abnormal temperatures. Normally it is around 25 degrees, but this time they have faced the temperatures of around 35 degree. And even the day-night temperatures were, even the night temperatures were also high. And what could be the reason? And that is the reason that they are having lesser yields, around 25%, 15 to 20% lesser yields, around 5 quintals per hectare. They are getting lesser yields on average value. And what could be the possible reason you think it is? Why it happened? It's abnormal temperature. How it affected the yields? Can anyone? Anji? Global warming. Anji. इसका कोई सोल्यूशन भी होना चाहिए था ना? क्या होना चाहिए था सोल्यूशन? नहीं, प्लांटेशन तक तो अभी मैं पहुंचा ही नहीं हूँ. अभी तक प्लांटेशन तक नहीं पहुंचा हूँ मैं. यू सी एकदम टेम्परेचर बढ़ा, उस टेम्परेचर में बढ़ेगा तो क्या होगा? ट्रांसपिरेशन लॉसेस विल इंक्रीज. If transpiration losses will increase, what happens? The plant will demand more water. But we are irrigating based upon thumb rules only till today. That is, you apply 4 irrigations if there is rain in the season, and otherwise you apply 5 irrigations. but there is no such contingency plan for such periods where crops or where weather is abnormal or deviate from the normal. So it means our technology could have been helpful to them. अगर हमारे पास टेक्नोलॉजी होती उस समय तो हम वो अपना मॉइस्चर सेंस करते और उनको पता लगता भी ये ट्रांसपिरेशन लॉसेस बहुत ज़्यादा हो रहे हैं, तो इसका मतलब है सॉइल मॉइस्चर उसमें से डेफिसिट आता, वो डेफिसिट को अगर हमारे पास कोई ऐसा सिस्टम होता हम उसको मैयर करते और उसमें पानी डाल देते तो हो सकता था जो हमारे लॉसेस है, ग्रेन लॉसेस है, वो इतने नहीं होते. ठीक है, बट स्टिल टुडे आप सब लोग कौन से फील्ड से हैं ज़्यादातर? इलेक्ट्रॉनिक, कंप्यूटर, मैकेनिकल, है ना? हाँ जी. तो उनके लिए इलेक्ट्रॉनिक्स कंप्यूटर वालों के लिए ये फील्ड ज़्यादा अट्रैक्टिव है. वो इसलिए अट्रैक्टिव है बिकॉज दिस इज अ डायरेक्टली अप्लाइड पार्ट. आपकी जो नॉलेज होगी वो हमारी नॉलेज के साथ अगर डोमेन नॉलेज के साथ आती है तो वी कैन डू वंडर्स हियर ओनली. Because till date, even today, even these sensors are quite costly. These automation systems are quite costly. But if they are made in country only, we can easily get them. We can easily install. My farmers can afford it. My smaller farmers who are having land less than 2.5 or less than 1 hectare can afford such systems. अगर वो afford कर सकते हैं, तो it means हमारा जो ये जो यील्ड लॉस आया उनको नहीं आएगा और दे विल बी डूइंग देयर कल्टीवेशन ऑन साइंटिफिक प्रिंसिपल्स. इरिगेशन साइंटिफिक प्रिंसिपल से जो अपने अब कुछ चीजें जैसे डिसीजन सपोर्ट सिस्टम्स है. लाइक यू सी देयर इज अ डिजीज कॉल्ड लेट ब्लाइट एंड अर्ली ब्लाइट इन केस ऑफ पोटैटो. तो उसमें वी स्पेसिफाई और हेल्प फार्मर्स इन अ वे. We predict that okay, these are the temperature, these are the weather protocols, and you can go in for preventive spray for such and such disease. So that is there on our website. आप अपनी वेबसाइट खोलिए, उसमें जाके चेक कीजिए, तो जो पोटैटो रीजन के जितने भी फार्मर्स हैं उनको वो इंफॉर्मेशन चले जाती है एंड दे कैन डू इट. और इन सिस्टम्स को जो कंप्यूटर साइंस वाले लोग हैं वो और बढ़िया कर सकते हैं और रियल टाइम कर सकते हैं. और जैसे मैंने एक फोटोग्राफ लगाई हुई है, इस डायग्राम में हमने वायरलेस सेंसर्स की बात कर रहे हैं. रिसेंटली वी गॉट अ प्रोजेक्ट ऑन वायरलेस सेंसर्स. So we have to develop this system, automate it, and we are collaborating with IIT Ropar and then CSSRI Karnal for development of this system. Here, what it is, there is a soil moisture sensor in every representative soil moisture sensor in every field with a solenoid valve in that, and then that is connected to the motor. Once the solenoid valve gives moisture sensor gives the signal, that signal is processed at the gateway, and then accordingly the decision is taken whether to irrigate or not to irrigate or how much to irrigate. But then when we talk of agriculture, actually mechanization of agriculture started from industrial revolution. There, when the new machinery came up, so they started replacing the animals and humans. The machinery started replacing animals and humans, and what happened was more and more, because whatsoever animals or machinery that was freed from the agriculture, that went to industries. Industry part, they worked over there, and it happened in such a way that in 2008 there were already more people in urban environments than in rural areas, and this upward trend is expected to reach 66% by 2050, up from 34% in 1960. सारी के सारा जो शिफ्ट है वो अर्बन रूरल से अर्बन की तरफ आने लग गया इसकी वजह से. और जो इसका कन्वेंशनल मॉडल ऑफ एग्रीकल्चर इज फंडामेंटली एन इंडस्ट्रियल डेवलपमेंट मॉडल. which views farms as factories and considers fields, plants, animals as production units only. And the goal of industrial development is to increase human well-being by increasing production or material goods and services, simultaneously increasing aggregate employment and incomes. That is the only goal of industry. That was the only goal of industrial revolution, and they treated agriculture also like that. And the underlying assumption of the industrial model is that a higher quality of life can be derived from increases in income and consumption of goods and services. A fundamental strategy for industrial development has been to specialize, routinize, and mechanize agriculture production in order to achieve the economic efficiencies that are inherent in large-scale industrial production. Ultimately, the goal is everything is production unit. It has a different components, different compartments. If you do this, you will get this sort of industrialization. And the new technologies are designed to remove physical and biological constraints to production and thus make unlimited progress possible. But when we talk of sustainable agriculture, it is a paradigm shift from conventional agriculture, because here we treat it as organisms. Everyone is part of it. Our total ecosystem is part of it. May it be humans, may it be our biodiversity, or may it be any other thing, constitutes the complete ecosystem. And we say that, okay, population, people are also part of it. Our socio-economic system is also part of it. Quality of life is considered to be a consequence of interrelationships among people and between people and the other physical and biological elements of their environment. And when we talk of sustainability, sustainable agriculture requires a holistic approach to farm resource management. And agriculture sustainability rests on the principle that we must meet the needs of the present without compromising the ability of future generations to meet their own needs. And therefore, long-term stewardship of both natural and human resources is of equal importance to short-term economic gain. Stewardship of human resources includes consideration of social responsibilities, such as working and living conditions of laborers, the needs of rural communities, and consumer health and safety, both in the present and in the future. And stewardship of land and natural resources is also involves maintaining or enhancing the quality of these resources and using them in ways that allow to be regenerated for the future. And you see, sustainable agriculture involves both environment, society, as well as economy of the region or state or country, whatsoever it may be. And the movement for sustainable agriculture is garnering increasing support and acceptance within our food production systems. And sustainable agriculture integrates three main goals: environmental health, economic profitability, and social equity. And a variety of philosophies, policies, and practices have contributed to these goals. But a few common themes and principles weave through most definitions of sustainable agriculture. And of course, when we talk of an agro-ecosystem and an agro-ecosystem and food system perspective is essential to understand the sustainability. And emphasis on a systems perspective allows for a comprehensive view of our agriculture production and distribution enterprises and how they affect human communities and natural environment. And of course, sustainable agriculture is not a single well-defined end goal. There are different type of components that come into sustainable agriculture ecosystem. Maybe if we start talking of sustainable agriculture ecosystem, it means right from inputs, it may be water, may it be fertilizers, may it be seeds, and the different people involved in it. Then we grow it, then it interacts with the environment, it interacts with the soil, then we go for post-harvest of it, then its utilization part, then its economic part, everything comes into it. And we cannot say that, okay, we are doing something like we are in running an industry. We are not running an industry. We are basically into agriculture, where everyone's involvement is must. May it be a farmer, may it be a industrialist, anybody who is on the earth is involved in the agri ecosystem. And if we talk of challenges in agriculture, the first challenge is ever increasing population. वो जिस हिसाब से बढ़ रही है और उस हिसाब से हमारी ग्रोथ नहीं हो रही है. And the first is to ensure global food security. Now the human population is expected to reach 9,000 million within 30 years. And today agriculture provides enough food to feed all the humanity. But by 2050, agriculture would need to produce 60 to 110% more. And you can see, even at if we go by today's production systems, we say that, okay, in the last 10 years or so, we have reached a plateau. We cannot increase much on what we are producing. It means that, but we have, our goal is to produce at least 60 to 110% more what we are producing today. So at least for the crops on which we base our calorie protein supply, production would have to increase by around 2.4% per year. Since our production levels are lower than what are the world averages, we are still sustaining at 3.6% average growth agriculture growth level. But that is not the case worldwide. It is around 0.6 to 0.8% worldwide. 0.9 to 1.6% worldwide in last 20 years. And in addition, the quality of human food must be improved, not only by providing enough calories, but also by ensuring a varied and balanced diet, the availability of which is not guaranteed either. Another factor that aggravates the problem is the growing demand for the meat products, driven by the increased spending power of the world's population. And if we talk of for instance, for 1 kilogram of beef, we require around 30 kg of grain, and 1 gram of beef protein requires around 112 liters of water, while 1 gram of cereal protein requires only 21 liters of water and gives us equal amount of protein. So you can see, by just going, even beef or any other meat product is not but they have a higher water footprint. They have a higher water footprint, higher energy requirement. And when we talk of India, so we always say that most of us are vegetarians. Most of us. It's not all of us are vegetarians. We have the largest vegetarian population in the world. But even then, we got water resources which are dwindling day by day, and you can just imagine what will happen after, say, 15 or 20 years. And the second challenge is that agriculture production must be based on sustainability criteria. Sustainability I have already discussed, and the cultivated agriculture land is currently 38% of the Earth's total land area, excluding Greenland and Antarctica. And this fact shows the impact agriculture has had on the environment, which is greater than that of any human activity we are doing. It has the greatest impact upon the environment, and water is often what determines whether agriculture can be practiced at any place or not. अगर पानी नहीं है तो कुछ भी नहीं है. We cannot practice agriculture. We can practice agriculture without soil. That is being done nowadays. But we cannot practice agriculture without water. It means Water, moreover, more than 70% of available fresh water is used to irrigate crops. And if we talk of Punjab, it is around 94% of water is used in agriculture only for irrigation purposes, and 70%, around 72% of that comes from the groundwater, and 28% of that comes from the canal water. So you can see we are just extracting like anything, and that is not sustainable even, because almost 80% of the blocks in Punjab are under dark zone, or under overexploited zone. When I say overexploited zone, it means whatsoever we are taking out, we are not recharging anything with the help through the rains. If the recharge is say 10 liters, and we are extracting out around 20 liters of water, and that creates some imbalance or mismatch, and that is the reason a number of problems are also coming up, like higher use of energy. That is the one thing. Then when the resources are dwindling, it means my energy costs as well as my other input costs also increases. And then biodiversity is another crucial element for the existence and preservation of life and even agriculture. We are not doing any diversified agriculture. We are into monoculture of paddy and wheat only, and that is also putting up a pressure on our resources. Earlier, when we started paddy, the yields were, there was a quantum jump of the we got a quantum jump of the yields. Say, around 10 to 12 quintals per acre, we got around 20 quintals per acre. But now that quantum jump has gone, our soils are, our soil fertility is dwindling, and of course, water resources are already dwindling. And when we are applying more with a less efficient irrigation systems, what happens is our soil fertility as well as soil salinity also increases, and that creates another problem. And the destruction of biodiversity on Earth would be an impediment not only to the progress of agriculture, it will also lead to imbalances that could make the lives of many of the organisms inhabiting the planet unviable. At the very least, it would contribute to the loss of some ecosystems, scenic beauty that would make the world a much less interesting place to live in. And of course, climate change is the third challenge, and a major contributor to that is the fossil fuels. And of course, agriculture and forestry directly generate an important part, 21% of these gases, which are contributing to the climate change. Agriculture produces these gases mainly as a result of deforestation, animal production, and soil and nutrient management, particularly animal-based organic fertilizers. And of course, UNO gave 17 Sustainable Development Goals for food security, and I mentioned here only some of them, and the main one is Goal 1 that addresses poverty. It calls for an end to poverty in all manifestations by 2030, and it also aims to ensure social protection for the poor and vulnerable, increase access to the basic services, and support people harmed by climate-related extreme events and other economic, social, and environmental shocks and disasters. And particularly, food security is the main part of it. And when we talk of food security, the goal number 6 comes into play, which aims to ensure availability and sustainable management of water and sanitation for all. Now, leave aside drinking water, people don't have water to wash their hands, which was the basic requirement for the management of COVID in the last 2 years. And even today, water is considered to be wash your hands with water is considered to be the basic protocol for कोविड. एंड जिनके पास पीने के लिए पानी नहीं है, वो अपने हाथ कहाँ से धोएंगे? So this is the situation, and of course it has to be improved. Then goals 7, 8, 9, and similarly other goals, I will not go much into them. And when we talk of food security, सस्टेनेबिलिटी के लिए हमारे जो challenges हैं particularly food availability के लिए, तो पहले आ जाता बायोटिक स्ट्रेसेस में disease और pest resistance, इधर हमारे पास ब्रीडिंग प्रोग्राम्स हमारे ऐसे हों जिसमें हमारे पास डिजीज और पेस्ट रेजिस्टेंट क्रॉप्स हों. अगर वो नहीं है तो हमारे पास डिसीजन सपोर्ट सिस्टम्स होने चाहिए उनको मैनेज करने के लिए, और हमें पता होना चाहिए बिफोर एंड भी वो कैसे कर पाएंगे हम. देन ऑफ कोर्स रस्ट रेजिस्टेंट वीट वैरायटीज, पेस्टिसाइड्स, हर्बिसाइड्स, टिलिंग मशीन्स, स्पेशल रिपेलेंट ऑन फार्म पेस्ट, and then improved agronomic practices that have to be placed for food security only. And then abiotic stresses, it may be salt tolerant crops, or it may be climate resistant crops, or improving crop productivity in general. It can be with the help of conventional breeding, it can be with the help of tissue culture and micropropagation, it can be marker assisted breeding, it can be advanced genetic engineering, or it can be low cost diagnostic toolkit for the extension workers, which is very much required. Like we are working on one project, that is one of my students is identifying the abiotic stresses on the maize crop. She is just clicking the photographs. Then she will be developing the algorithms, AI-based algorithms. That algorithms will match the photograph, and then they can easily tell from those algorithms. The farmers can easily interpret, okay, this is the deficiency and this is the work I have to do so that this deficiency can be removed or elevated. And then, of course, improving livestock agriculture, that is also one of the requirements. And then lack of water availability is the major issue in water in agriculture. And of course, we say that, okay, go for water storage technologies, may it be subsurface water storage technologies, may it be aquifers, ponds, tanks, low-cost plastic water tanks, natural wetlands or reservoirs. Then we are also devising methods so that the evaporation from those water bodies can also be decreased. And then, of course, canal irrigation and micro irrigation technologies like drip irrigation, bubbler, micro sprinkler irrigation. These technologies play a major role in in increasing the water use efficiency. Normally, the systems we are doing at present in Punjab is around conventional flood irrigation methods, and they are least efficient. When I say least efficient, it means the efficiency is not more than 30%. And whereas in case of micro irrigation methods, this efficiency is more than 90%. But then the problem is these systems are capital intensive and we cannot say that, okay, in one go we will bring all the area under micro irrigation. We say that, okay, phase wise we can do that. And then, of course, water lifting devices, may it be hand powered mechanical pumps, straddle pumps, solar power irrigation pumps, hydrogen powered pumps, or electrical and fossil fuel pumps. Then, of course, fungal and seed plant treatment for water related stress. Then stabilized salicylic acid for drought tolerance, irrigation scheduling systems. That is, I have already just discussed. Then plant technology for increased water use efficiency. Then water buffering technologies, then rainwater harvesting mechanisms, may it be rooftop rainwater harvesting, or may it be rooftop rainwater, groundwater recharging. Then the water desalination technologies in the areas, particularly the arid areas where the groundwater is brackish. There we say that, okay, if you want to promote agriculture in this area, there are two ways only. Either you go for canal water irrigation, or you go for desalination systems where you desalinate the underground water which is brackish. The EC of such water is around 5 to 6 decisiemens per meter. And then, of course, wastewater use, conservation agriculture, then portable sensors for groundwater detection. And this is one other area where we are working on. we want to make our groundwater transparent. And to make it transparent, when we say we want to make the groundwater transparent, it means that you can see what is happening underground. Now your sensors are in place in the piezometers. The piezometer is a pipe which we insert up to the into the aquifer, and that measures the groundwater level. And even today, till date, the groundwater for measuring the groundwater level, we have got it is a sort of दो तारें लगी हुई हैं उसके साथ बजर लगा हुआ है जब वो पानी को टच करता है तो उसकी रीडिंग आती है बट वी वांट टू रिमूव दैट ह्यूमन इंटरफेस इन ह्यूमन इंटरफेस जो है वो हम उसमें से रिमूव करना चाहते हैं भाई बिकॉज होता क्या है अभी मेरी रीडिंग अगर मुझे 10 बजे चाहिए या 12 बजे चाहिए या महीने के 5वें दिन चाहिए तो उसी दिन चाहिए उससे आगे पीछे आती है तो मेरे रिजल्ट्स जो है जो मैंने उनसे प्रेडिक्शन करनी है वो कभी भी ठीक नहीं कर सकता तो इसका मतलब है कि मुझे उसका अगर मेरे पास कोई ऐसा सिस्टम हो जो मेरे अपने ऑफिस में बैठ के या मेरी लैब में बैठ के उसकी सारी रीडिंग्स चाहे डेली की रीडिंग्स हो चाहे आर्ली रीडिंग्स हो वो सारी की सारी मुझे अपने ऑफिस में मिल जाए और विदाउट एनी ह्यूमन इंटरफेस तो इसका मतलब है वी आई विल बी गेटिंग द बेस्ट ऑफ द थिंग्स और मैं सभी को बता सकता हूँ कि ये देखो जी ये आपका जो ग्राउंड वाटर बैंक है इट इज आप उसमें से निकाल ज्यादा रहे हो पैसे ज्यादा निकाल रहे हो पर आप उसमें डाल बहुत कम रहे हो एंड अल्टीमेटली आपका नुकसान किस हिसाब से होगा व्हेन वाटर टेबल गोज डाउन what happens is we have to again rebore it and then have to make an additional investment. In Punjab, almost all the farmers are making additional investment of 50,000 to 1 lakh after every 2 or 3 years, particularly in Sharda belt and then in Sangrur belt. So ये जो काम है ये थोड़े थोड़े काम जो है इलेक्ट्रॉनिक्स और कंप्यूटर साइंस वाले जो लोग हैं उनकी हमें मदद चाहिए होती है भी सो दैट दे कम बिकॉज इट्स देयर डोमेन नॉलेज आपकी डोमेन नॉलेज है और आपकी जो एप्लीकेशन है वी कैन इजीली टेल यू ओके ये चीज हमारे यहाँ पे काम आ सकती है and then of course soil is another challenge we are using synthetic and organic fertilizers biogas digesters slurry preparation then biochar natural fixation nowadays people are even working on fixing nitrogen from the environment for the plants and then, of course, need for precise integration scheduling of inputs for increased yields. It may be imaging and associated analytics. It can be drones. It can be Internet of Things. It can be big data analytics, or it can be farm management software and applications. Then farming in urban environments, that is another upcoming field. It can be indoor farming, it can be a vertical farming, it can be aquaponics, or it can be low-cost greenhouses. Last year, we got a request from around 50 urban farmers. They said, okay, we want, since being a corona period, they asked, specially requested for training on hydroponics, vertical farming, and soilless farming. And then, of course, power and control intensive operations may be tractors, may be robotic technologies, or may be animal-drawn implements. We have to improve everything. Yesterday only, I got one of the mechanical engineers visited my lab in hydroponics lab, and he is doing PhD in robotics. He is developing a robot so that we decrease the human intervention in such systems where बिकॉज होता क्या है कि जब आप पॉलीहाउस या किसी भी प्लांट फैक्ट्री या फिर किसी भी सिस्टम के अंदर जाते हैं तो उसमें इंसेक्ट पेस्ट की एंट्री बड़ा तंग करती है और अगर हमारा वो सारा का सारा सिस्टम जो है ह्यूमन इंटरफेस के बगैर है तो वी कैन इजीली मैनेज दैट सिस्टम्स वेरी वेल बिकॉज दे आर हाईली कॉस्ट इंटेंसिव ऑल्सो और उसमें एक बेनिफिट
Yes.
Then, of course, food preservation technologies we are using. Then thermal battery powered milk chillers, nanotechnology. Then use of IoT, particularly in refrigerated vans. Even in during COVID, when they were transferring these vaccines from one place to another, there also those IoT-based temperature devices were used so that they can detect whether at any place driver has not switched off the refrigeration system or something like that. Then, of course, cleaning, grading, and packing technologies, low-cost refrigerated vehicles, low-cost solar dryers, everything is available in the world. But only thing is the price. When we say we will indigenize it, it means we will reduce the cost, and that will come. That will be a pocket friendly for our small farmers. Don't go. And then talk about sustainable water management agriculture. In agriculture, if you see this figure, all the red portion is overexploited region, and whatsoever the green region there is, it is that is safe one. But even that this safe area there on this side, this is southwest Punjab, where the groundwater is brackish and it is not utilizable. That's why it is within the, we are not extracting anything out of it. So it means it is in the safe range. Whereas in the upper region, the water is good for use in agriculture, but the problem is the water table depth is very high, around 400 to 600 meters. So it's not viable for the small farmer to harness this water. So this is also the safe zone. But then all other zones, you can see it is a red in color and it is a overexploited. And if we talk of water scenario of Punjab, around from dams we get 14.8 BCM. From rainfall it is 26.3 BCM, billion cubic meters. Treated water is around 1.26 billion cubic meters. When I say treated water, it is the water we get from STPs. And we are using it for irrigation. And then, of course, return flow is around 10.7 BCM. Subtotal is 53.06 BCM. And the rest we are getting out of drawdown water or water withdrawal from the deep aquifer. It is around 13.06. And the total we are extracting is 66.12 BCM of water. And 1.2 BCM is used by the rural domestic people. Population, then urban domestic population is using around 1.14 BCM. Then industrial demand is around 1.13 BCM and agriculture demand is around 62.58 BCM. And the actual gap which state met through over the exploitation of the groundwater is 13.06 billion cubic meter. So 94% is used in agriculture, domestic 3.8, 0.7, 1.0, and then livestock it is 0.2%. And this is how our cropping pattern has changed. In 1970-71, the major area was under under rice. It was only 3.9 million hectare, 3.9 lakh hectare area. But you see, as we moved from 1971 to 2019-20, it has increased to 31.4 lakh hectare area. And this increase has contributed to the overexploitation of our groundwater. And there is a need either to shift, either to diversify our agriculture. That's what we tell our farmers. But of course, when I say that it is a socio-political as well as a complete agro ecosystem, which जो फार्मर्स को लगता है भी अगर हम किसी और क्रॉप पे जाएंगे तो it will not be as remunerative as paddy is. तो वो जाते नहीं है. इस बार सिर्फ इतना फर्क हुआ है the area under wheat has reduced, and that is because of the financials of the this सरसों. उसके financials better थे mustard crop के. That's why people have shifted from wheat to mustard, because last year they get around 7,000 rupees per quintal. So they shifted because it is more remunerative. So they have shifted to that crop. A good trend. Let's see if it will be such some alternative available for paddy crop also. And of course, when we say how to manage, it can be water supply and demand can be easily managed, either by increasing the efficiencies of the system or by using all such technologies. If we say on water supply side, it is a canal line, it can be a lining or revisiting water allocation systems, or it can be even in water allocation systems also. We need the people, computer science people. Now, they can give us a better AI-based decision support systems with which we can have a real-time water allocation. And even some people are doing work on climate analogs also. When I say climate analogs, it means whatsoever I am doing at one place, and say in 1920, I can replicate the same thing in some other place in 1940. So I want a climate analog. Whatsoever research I am doing at this place in time, it can be replicated, and people are doing work on it. And of course, agriculture runoff has to be taken care of. Rooftop recharge pits, stormwater recharge has to be managed. And then, of course, there's another field that is paleo channels. We say that okay, if we puncture the channels, we can store the excess flood water into them. And then on the water demand side, it can be crop diversification, or it can be even we go for breeding. Like we say that okay, we have developed two varieties at the university, which are short duration varieties. It means normally the paddy variety is harvested in around 110 to 115 days, and we have developed a variety which is harvested in 92 days. And as such, that will consume less water as compared to the long duration variety. And then of course another technologies such as direct seeded rice. Direct seeded rice जो है, हम normally rice जो है puddle transplant करते हैं, उसको रुपाई करते हैं उसके बाद में. But now we are popularizing direct seeded rice. उसमें हम seeding ही direct field में करते हैं. उसमें जो पानी की तकरीबन 15 to 25% जो पानी की सेविंग होती है. लास्ट ईयर कोई तकरीबन 5 लाख हेक्टेयर एरिया वाज अंडर डायरेक्ट सीडेड राइस. Then of course laser leveling, micro irrigation, optimal plot sizes, underground pipeline systems, mulching and tillage, this also. And of course it requires a policy intervention also from the government. And if we simply increase the efficiency from 40 to 60%, you can see we can become water surplus simply by increasing. But then this is quite cost intensive also, so we say we can do it in phase wise. This is the different when we are using micro irrigation technologies, we got increase in yield, saving in fertilizers as well as increase in no. Then also of course one scheme is पानी बचाओ पैसा कमाओ, in which आगे क्या था, हमारे फार्मर्स जो थे वो आगे नहीं आ रहे थे. हमने उनको कहा भी आप ऐसा करते हैं, आप अपने यहाँ मीटर लगाइए, हम ये मानते हैं कि आपको इस क्रॉप के लिए 1000 यूनिट्स लगेंगे, 1000 यूनिट्स ऑफ इलेक्ट्रिसिटी लगेगी. अगर आप 1000 में से हमारी जो बताई हुई टेक्नोलॉजी है वो यूज करेंगे तो आपको सिर्फ 600 से 700 का खर्चा आएगा. 600 से 700 यूनिट खर्चा आएगा. इसका मतलब 300 यूनिट आपके बचेंगे. वो जो 300 यूनिट आप बचाओगे उसके हम 1200 रुपए डायरेक्टली आपके खाते में डालेंगे. तो उसमें भी अभी भी कुछ पॉलिटिक्स चल रही है. कई अब हमने नंबर ऑफ फीडर्स तो इंक्रीज कर दिए हैं, पर अभी फार्मर्स उतने नहीं आ रहे. वो कहते हैं जी अगर आप मीटर एक बार लगा दिया तो हो सकता है दूसरी बार आप उतार के ना लेके जाओ, अगली बार बिल लेने लग जाओ. पर उनको द गवर्नमेंट इज गिविंग रिटर्न एश्योरेंस फॉर दैट. Then of course I have already told you we are going in for 93 days crop PR 126. This is one short duration variety. Paddy yield is also there, and then we save on water also. And then this is another one project we are working at Bathinda. This is utilization of brackish water for fruits and vegetable production in southwestern Punjab. Here we have put up a desalination plant for desalinating water, and then that water is being used for irrigation purpose. And of course, AI in different types of irrigation systems can be used. It has a good application. If you go to internet, you will find papers in thousands. You will also find decision support systems for the use of AI in drip irrigation or in micro irrigation as well as in the irrigation, because these being the non-linear processes. So in the non-linear processes, AI plays a good role and gives us good results. And this is one of automated fertigation system which we have developed at our place. And of course, this is a little bulky one which we have designed. It has to be made compact. And moreover, the cost of this system is only 3.5 lakhs, whereas the cost of the system which we purchase from the market is around 12 to 15 lakhs for same functions. Don't go much into it. These are the different sensors and dosing pumps. Then this is the soilless cultivation. Now, actually the thing is we have to make the things sustainable. होता क्या है भी जब आप पॉलीहाउस में सेम जगह पे क्रॉप बार बार लगाते हो तो योर सॉइल गेट्स फर्टिलिटी गेट रिड्यूस्ड, ईसी और पीएच सॉइल की बढ़ जाती है और ईसी को मैनेज करना इट्स डिफिकल्ट टास्क इलेक्ट्रिकल कंडक्टिविटी को. तो व्हाट वी डू इज सैलिनिटी लेवल्स को कम करने की बजाय हम कहते हैं गो फॉर soilless cultivation in your farm, and that is the solution, and that gives you higher yields also. And of course, this is my last slide. Component approach focusing on individual farmer practices and environment may have been appropriate for the era of agriculture industrialization, but nowadays system approach which focuses knowledge-based development of whole farms and communities will be required to address the environmental, economic, and social challenges of the post-industrial era of agricultural sustainability. And sustainability is the buzzword, and that is required. Even at our homes, we say, okay, if we want to sustain, we want to use the drinking water, we want to get the regular supply of drinking water, we have to use it sustainably, and we don't have to remove anything out of our ecosystem whatsoever. Even wastewater we are producing, it has to come back to our ecosystem only. And right now there is only one country which is bringing back that wastewater into its ecosystem, that is Israel. They are doing it 85% back to their ecosystem, whereas the most what we consider the most developed nation, that is US, they are doing it only 10%. That's all. Thank you. कोई question है तो I can ask. You can ask, I can answer.